Yoram Heller from Morph Labs. I also have Christopher Ado here as well.
All right.
And Sam White. So we can feel free to ask as many technical questions as you guys want.
Due to the time constraints, what we're already in progress right now of doing is installing on bare metal Ubuntu, which will then reach out to our Puppet Master server and pull in the manifest to stand up OpenStack on that bare metal or on that server. We're also from the same installer, also on bare metal, setting up Nexenta, which we use for our volume storage, using the Nexenta volume driver. So that's running right now on another terminal. And over here in this window, I'm watching our Puppet Master server. And in a little while, when the first Ubuntu server is up and running, it will register itself with our Puppet Master and start pulling down all the manifests and getting OpenStack up and running.
So do you mind giving a quick overview of your solution before jumping into the details?
Yeah, of course.
Yeah, thanks.
The reason that we wanted to start with this is going to be running in the background.
Got it. Okay, thanks.
So just to give everybody a little bit, right, where's yeah. All right, cool. Just to give everyone a little bit of a background on us, so it'll set some context for who we are. We're located in Los Angeles, and we have 55 employees. We're actually operating around the world, and we have a specific focus on Asia and Southeast Asia, and we've actually built a couple open source companies in the past. We're also members of the OpenStack Foundation. So most importantly, what is it that we do? We make converged infrastructure solutions for OpenStack. So we work very closely with Dell. Our solution is powered by the PowerEdge C series from Dell. We also use Arista switches. And the way that we actually build our solutions is to leverage the best components that are out there. For block storage, we specifically use Nexenta. And within OpenStack, we use Nova Volumes, Glance, and Keystone. But we've written our own UI, which sits on top of the fog layer, which is a Ruby cloud library, and we're going to be showing you guys a demo of that afterwards. And there's a couple of unique things that we've done in building our solutions. So everything that we've experienced, we've been deploying cloud solutions for the last 3 years. And about a year ago, we realized that cloud is much more of a systems problem as opposed to a software problem. So a lot of our customers that we were working with didn't necessarily have the time to optimize and integrate and do all of the things necessary to deploy these complex, networking topologies and everything that makes cloud pretty difficult to do. So we started doing these converged infrastructure solutions, and we're constantly improving on that. So we have an all SSD compute model. So you have the hyperscale architecture where you have compute and storage on the same blade. And we've essentially eliminated the IOPS barriers that you have generally with public clouds. We've also eliminated a classic enterprise SAN, which does a couple things. It reduces the barrier to entry quite a bit. Everything is based on the DFS-based file system, so we can tier out the storage, and we do SSD optimized read and write cache. There's multi-hypervisor support, although we do prefer KVM Ubuntu. We do incorporate a lot of elements of Puppet. We're a Puppet shop, and we'll talk a little bit more about that. And it's a full integrated support model directly from us. Does anyone have any questions really quickly? Great. So we hit on this a little bit before, but we have all SSDs replacing kind of stand speed IOPS that you normally have to have. So instead of going out over the network and using a shared storage platform, we can have it directly on the blade, which allows us to do a lot of really interesting things around the price performance metrics that we can drive. The storage nodes are also pretty innovative. So you can think about this as kind of blocks of elastic block storage, and you don't have the natural limit of 1 terabyte that you would normally have on Amazon, and you can also scale these much more dynamically. And then we also do a fair amount with OpenFlow and software-defined networking. So we've actually opened up the Arista switch and written some software on it that allows us to dynamically scale our environment, which means we can add physical resources on the fly to our dedicated private cloud. So one thing I haven't mentioned is everything that we run runs on a share nothing infrastructure. So we found that to guarantee quality of service, it means a lot to actually have guaranteed and dedicated hardware. And so every private cloud that we deploy runs on its own compute nodes and own storage nodes. And when you want to scale these, you can actually scale them directly on the switch and add more compute nodes on the fly or more storage nodes. So ultimately, you're able to have virtual private clouds or hosted private clouds that can scale on demand. This is just a little bit in terms of our software stack. So if you look at the bottom, we use Crowbar, and this is a component of our solution. We're a Puppet shop as well, so we've incorporated components of Puppet within Crowbar, and we're working to do that more as well. In terms of the distribution layer, we use Glance, Keystone, Nova Compute, Nova Volume, Quantum, and the scheduler. But we do incorporate Nexenta, as I said before, as well as Sensu for the management layer. And then a lot of what our kind of secret sauce is and what we've built is around the Fog API layer, which is a Ruby cloud library, and we've actually extended the support to include Essex. And then we have our own web app that we built on top of that layer, which is our mCloud UI. So we can go ahead and show that to you right now. Does anyone have any questions?
So you mentioned that your target was price performance. I wonder if you can compare it to, not dollars and cents, but ratios, to using SANs versus using JBODs and magnetic as opposed to SSDs.
Yeah, so we think about it, we try to use kind of a similar kind of metric from what you would get from Amazon, like the idea of an ECU, elastic compute unit, or, you know, a price per terabyte. And all in, we actually are able to drive pretty much the same price, but the performance is greatly increased because of the use of the SSDs. So all of the VMs boot off of SSDs and run on SSDs. And in terms of the JBOD, we actually use kind of a tiered model. So we use SSDs for the read and write for our block storage, and then use a JBOD for the rest of the storage. Does that answer your question?
Mm-hmm. Good enough.
Okay. Yeah. So right now, Christopher's going to go ahead and show you the UI. So this is all running on top of OpenStack, but you'll notice that this is not running Horizon. This is running our UI. There's a couple reasons for that. We think that, you know, Horizon is a good solid start, but it's not going to be everything that's necessary for enterprises. It's meant to be kind of a showpiece for OpenStack, but there's a lot more that's necessary for an enterprise-grade infrastructure, and there's some of these things that we've built into it and are planning to build into it over the next several quarters.
So we start off at the dashboard, which gives you a high-level overview of all the projects that are running. So there's one block for each project that's been fired up in this environment. And then you can drill into any one of those projects, and it'll give you, again, another block for each VM. So if you've got 50 VMs, this is still scaled through and nicely and shows you at a glance the health of those VMs, whether they're up and running or you're getting, receiving errors from them or anything else. Then within each, at the Projects tab, obviously gives you a list of all the projects that are set up in this environment. You can drill into any one of those projects. And it'll show you the instances that are running and any volumes that have been provisioned within those within that project. You can allocate and assign floating IP addresses and create security groups, also from the Access and Security tab. And if the screen refresh is not happening fast enough for anyone, please speak up and I'll try to move extra slow. I know that for a few people, at least, you're probably seeing it through link in addition, but still speak up if we're moving too fast. We've got a snapshot tab, so you can take a snapshot of an instance and then launch that snapshot for pretty easy duplication of anything that you've set up. And then on the Collaborators tab, we make it really easy to add new users. So if you're you want to bring a couple people into an environment that you've already set up, you can just click Add Collaborator, and you'll get it'll bring you to the User Creation tab, and you can add a new user and bring them right into this particular project. So back on the Instances and Volumes tab, and I'm watching on another screen, just wait for the display to catch up here. Back on the Create Instance tab, you've got the option to choose one of the flavors or one of the server images that are installed. In this environment, we've only got 3 Ubuntu images installed, but anything you can run under KVM or OpenStack, you can run here. You can choose any one of the available sizes for the server, or the flavor information, so the number of virtual cores and the amount of RAM that you're going to assign to it. And we have a little slider to make it really easy for you to launch multiple copies at once, so you can slide this up and launch a whole bunch of servers at once, or just launch one at a time. Assign the key pair and the security group that you'll want to associate with this instance, and then create instance. And in about 4 to 8 seconds, that instance will be up and running, and it will not have a public IP address by default. Once the instance is running, you can go back to the Access and Security, and if you want to VM to be available with an external IP address, you just assign a floating IP to it. So after you can, in addition to assigning a floating IP address, you can also, from the instances and volumes pane, you can create volume, and this creates it on the Nexenta store. And after you create the volume, you attach it to the instance. And now if we SSH into that instance, we'll see that volume now has, it will have that, so it will be attached to server 1. I've used that IP address before, so I need to clear out my key.
Yeah.
Life goes on.
Yes.
And if we do a quick F-disk minus L, we will see that on device VDC now we have a 107 gig volume attached, which we can format with whatever file system we want and attach it or mount it wherever we need it. In addition to that volume, once we format it and done whatever we want to, we can take a snapshot of that volume and then essentially duplicate whatever is on it and use it with any other virtual machine that we want. We can attach it to another virtual machine. And
there's a question here on IM. Question is, do you support Swift in your solution?
We actually don't support Swift, so one of the things that we've seen is there hasn't been a great need for an object store in a lot of our deployments. So having persistent block storage has been a much bigger demand, hence our use of the Nova volume drivers for Nexenta.
The follow-up question is probably, so what's the profile of customers you're deploying at?
Yeah. So we deploy at Global 2000 enterprises. There's a couple workloads that we really try to focus on. So we've been doing, since we're based in LA, we do a lot of like HPC and animation. Rapidly deployable websites has been a pretty big thing for us. We originally kind of came from a PaaS background. So we're always very good at deploying applications on cloud infrastructure. And we also have been working with several other SaaS providers who've actually been incorporating their software and deploying the solution directly on-premise for people who have some compliance issues. And then finally, I think the classic cloud one that has been most of the focus for a lot of deployments right now is a lot of build and test scenarios, so being able to spin up lots of VMs and kind of bring them back down.
So can I ask you a question? So so are they just tying into their existing storage?
I'm sorry, you just echoed a little bit. Can you repeat that one more time?
Are they tying into their existing storage?
One more time. The echo is kind of clear. Or you can just Skype or the web app.
Let's try, maybe my voice is less echoey.
Okay, go on.
Are they tying into their existing storage for?
Yeah, that's been something that we've also had to have a focus on. So obviously, if you have large pre-investments in SAN, that's a very big piece. That's also why we're contributing to Nova volumes, and that's something that we're definitely focused on. We don't, this is meant to be a greenfield implementation, and we're going to have some announcements about this over the next quarter in terms of being able to shrink this almost to the point where it's an appliance model, so to speak. But it's a good question, and it's something that we also have to focus on.
So the other thing I noticed is you use Puppet for deploying OpenStack. Can you talk a little bit about how that works?
Sure. So similar to the way you guys are using Chef, our first phase is essentially just to get just enough operating system on the hardware so that it's up and running, and we leave it as clean as possible. And basically the only thing we really install is a Puppet agent and point that back at our Puppet Master server. And then within the Puppet Master, we're using Factor in order to determine some local things on each machine, so that there are just a few core variables that we set up in one file for each individual environment. So we're able to continue to use a Puppet server to maintain we're using the Puppet server as our sole source of truth for all the environments that we are running and that we've configured, and that way they stay consistent. And then we work with the team at Puppet Labs we've been working with Puppet Labs guys on the manifest that we use for setting up the different components of OpenStack. And that includes our own custom web interface, which is the last thing that gets pushed into the environment. So within the Puppet Master, we know the IP addresses of all the machines that will be part of any individual environment. So we're able to configure all of the compute nodes to tie back to the controller node. And we also add the config of the Nexensa storage node in there as well. So it's nothing abnormal with Puppet. It's really, we're using Puppet the way it's meant to be used. So it's turned out to be a really convenient way to stand up OpenStack for us.
You were describing this process very similar to the way Crowbar works. The parallel to Factor in Chef or Crowbar is Ojai, which has a very similar overall architecture of pull the information out of the node and stick it in the master for future reference. The details of how things get connected to each other are slightly different. I guess Chef, we use more search, although we're reevaluating pushing information via node attributes, which is the equivalent of Puppet manifest. But we're all happy. In a previous session, I was comparing Puppet. The differences between Puppet and Chef to mostly religious.
Yeah, that's absolutely true. And the reason we went ahead with Puppet is that we've got a lot of expertise in it, and like Jordan was saying, we've been doing this for several years. We've got a lot of live environments, and we're already using Puppet to manage and maintain those environments. So for us, it made a lot of sense to continue that way. The other consideration that we have is we like to maintain a single point of config for all of the environments, or in essence a master config. So even though each of the environments are share nothing and stand alone, for purposes of our own sanity and to make our support work the way it needs to, we wanted to have really that one source of truth for all the different environments, and it's made it really easy for us to do that with Puppet. And really to do it in ways that we're already familiar with. So for our support team and for our ops team, we didn't have to do a lot of rethinking or relearning.
That makes perfect sense. One more quick question related to your UI. It seems to overlap considerably with Horizon. It definitely adds cool things, and the organization is definitely convenient. Were those the main drivers to invest in building it from scratch, or was it not from scratch? Or what led to the decision to effectively build it?
There were a couple things that led to us developing our own interface rather than just implementing Horizon, or implementing Horizon and doing a lot of add-ons to it. Number one is we've got a really strong Ruby team in-house, and we wanted to translate our existing interface over to OpenStack, which for us, our existing interface was already in Ruby. Also, it gave us a good excuse to extend the FOG API, and hopefully through that, increase the number of Ruby people using OpenStack. So all of the work we did with the FOG API to tie it into OpenStack has been open source, and
I think it's already been accepted upstream. So one of the biggest drivers for everything we do with OpenStack is to increase the community, and that was one thing that we knew we could do right away was bring a lot of Ruby people into OpenStack. And there are some other things that we are working on internally that we can't show in this demo, but there are a lot of enhancements that you won't see in Horizon and probably never will that we're developing in our own interface.
And that's just because that comes from, you know, normally when you work with an open source, there's an intention to kind of take it 80% of the way there, and then, you know, as you productize and commercialize something, or you build it internally, you know, you're supposed to do kind of the last 20% for what you need. And so that's a lot of the work that you're going to be seeing. So, you know, another key point that we haven't really talked about enough, but we did a total rip and replace from Eucalyptus to OpenStack in 45 days. And this is kind of the first iteration of what you're doing, of what we've been doing. So there's going to be a lot more innovation coming from this UI. And generally, we think that writing a UI in Ruby and a front end is a lot better than doing it in Python for several reasons.
Okay, guys, do you have something more to show with the demo? We are at the top of the hour. And
I think we're all good. So
okay.
Feel free to transition over to the Join Me. We'll be on in another 5.5 hours if you guys have any more questions or if you want to run through this again. And thank you very much for setting this up.
Thanks a lot for joining us. Appreciate